Hello, sir.
Hello, Adam. How are you?
I'm good, sir. How are
You're
you?
doing good. I'm doing good as well. Thank you for asking. Um, Hold on. I'm still trying to look for that question paper we had before. Okay,
Nice haircut, sir.
sure. All right, I found it. So hold on. Okay, so again, as usual, I'm gonna stream this into YouTube so you can have a reference later on. Okay.
Okay.
All right. So where did we stop? Ah, yeah. Okay. So here. Okay. Okay. This is paper 2. We've already kind of we're done. We're halfway done with paper 2 that we were doing. Um. Spring constant is done. Main sequence, we don't need that. Done, done, done. Okay. So, all right. So this is the question we finished last time, right? So describe. Okay. Okay. So in this case, so describe how the distance of the image from the lens decreases as okay. In this case, it says you have to describe how the distance decreases as the distance between the object and lens increases. In this case, it's not a linear. It doesn't. You can have this. You can say here, the distance does not increase, decrease linearly with the the image distance. Let's find that image distance, the object distance. Okay. All right.
Okay.
Okay. Okay. So let's go now to the next question. Just let's move this a bit. Okay. So the next question here is this. So the student measures the distances or the distance from the image to the lens 4 times. Um, the distance between the object and the lens does not change. Okay. Okay. So these are the 4 measured values. So your task here is to calculate the uncertainty in the measurements. So again, how do you what's the fastest way to do an uncertainty here? Let's see if you remember that.
Sorry, could you repeat the question?
All right. So what's the fastest way to calculate an uncertainty given these 4 values?
Plus minus 0.4.
How'd you get that?
Because it's 2.2 minus 1.4
Okay.
over 2.
All right. You have to show this
The
working.
largest and the smallest number.
Okay. You always have to show this working. Okay. 2.2 minus 1.4 divided by 2. Okay. If you don't show the working,
Yes.
there's a chance you won't be given the mark. Even though in reality you're usually given the mark, there's a small chance you won't be. Okay, so just to be safe, put that in. Okay, now we have a next question. Figure 9 shows a spotlight containing a convex lens like this, and then a red filter is placed in front of the spotlight. Spotlight is directed at the blue object. Okay. So the question here is, explain why the blue object appears black. Why does this object appear black? Okay, you have an okay, 3 marks. I'll give you a few moments.
Okay.
All right.
Okay, so
Mm-hmm.
only red is transmitted by the filter, and red is absorbed by the blue object. So no light is reflected by the blue object.
Correct. Through filter. Then red absorbed by blue object. Correct. And then the last one, no light.
No light is reflected by
Okay.
the blue object.
By the blue object, by the ball. By the object. Okay, correct. This gives you 3 marks already. Good job. All right, next one. Okay, next one is here. Okay, so this is now the next question. Or the next section. So first of all, you have ultraviolet. It's a type of electromagnetic wave. Give one use of ultraviolet. Give one use of ultraviolet.
Sir, could you scroll up?
Hold on. Sorry. Just copy this. There you go. One use of ultraviolet. Excuse me.
One use is sun tanning.
Sun tanning. Okay, that's possible. Okay. Well, that's the most obvious one you could think of, right? Okay.
Yeah.
How about in medicine?
I mean, it's also used in. Wait. It causes the body to produce vitamin D.
Okay, that's another one. Okay. Okay, another one that one answer here that I think would be very really acceptable would be in terms of disinfection. You can use UV to disinfect or to sterilize objects. The better word here is sterilize. Okay, so your answers are correct. I'm just giving you a third possible answer. Okay, so let's go back here. You said tanning. Let's just put those tanning beds. Tanning. Body uses UV to produce vitamin D. Sterilization of instruments of material. Excuse me. Okay. Sterilization of materials. There are other uses. Okay, this is the most... I think this is the safest answer though. Sterilization of materials. Okay. Another possible one I'll just add to this is detection of certain substances. An example here would be fluorescent dyes in money, right? Fluorescent dyes in money. Basically, this is one way to prevent counterfeiting of money. Okay, all right. So again, these are a few possible answers. There are a lot more, but we'll stop here. Okay, so here we have an ultraviolet wave given that it has a wavelength of 300 nanometers. Which one is 300 nanometers?
Could you, like, your screen is like only showing half the page, that's why I can't read.
Oh, okay, hold on, let me do that. Okay, there.
Yeah.
Scoot it over.
It's the second one.
The second one. Okay, that's correct. Okay. Okay, just quick explanation. You can always think of this as 300 times 10 to the minus 9, which corresponds to this. Okay, next. Here. So the speed of ultraviolet waves is given here, 3 times 10 to the 8 meters per second. Calculate the frequency given the answer in the previous question. So I'll just do this first so you can see that more clearly.
Sorry, can I see the frequency sheet again?
Oh, the frequency given is no, the wavelength given is 300 nanometers, which is this.
Okay, 300.
3 times 10 to the minus 7 meters.
So 3 times 10 to the power of 8 equals to the frequency times 3 times 10 to the power of negative 7.
Correct. So
if I rearrange that, I'll get frequency equals to 3 times 10 to the power of 8 over 3 times 10 to the power of 7.
okay, correct. 3 times 10 to the minus 7 meters times frequency. So correct, frequency is equal to that times 10 to the 8 divided by 3 times 10 to the minus 7, which gives you 1, right?
Which gives me 1 times 10 to the power of 15
Correct.
hertz.
15 hertz. Correct. Okay, good. Next question. Well, that's an easy 3 marks. All right, you have this table. Table 1 gives the wavelength of an ultraviolet wave and 3 other electromagnetic waves. Draw one line from each wave to the name. So which one is wave E, wave F, and wave G? So I'll just copy this onto the Jamboard later. Okay, so this, which one is which? So one line from each wave to the name of the wave. Make this easier here. If you need help, I'll just zoom out a bit there so you can see that more clearly. Okay, so basically the idea here is you're comparing wavelengths. Which one has a long wavelength and which one would have a short wavelength? Which one would have extremely short wavelengths?
So wave E would be X-rays.
Okay. I'll put that on the board. So wave E is the X-rays. How about wave F?
Wave F is visible light.
Alright, correct. That makes that this, right? Correct.
Yeah.
Okay. You don't even have to memorize these, yeah? You don't have to memorize the actual wavelengths. Once one is given, you just have to think of relatively which ones should be shorter, which one should be longer. Okay.
Yeah.
Alright, next.
Common sense sheet.
Yeah, this one is... This is really easy, I think. So electromagnetic waves are transverse. Some other types of waves are longitudinal. What's the difference between transverse and longitudinal waves?
I know the exact definition for it.
Okay. So actually, if you know the definitions, that would tell you.
Waves, yeah. Oh yeah, continue, sir.
Okay, go ahead.
Or do I say, or you?
Yeah, you have to say it so I want to see how many marks you'd get from what you'd say.
Okay. In a transverse wave, the oscillations or vibrations are, can I say and vibrations or just say oscillations?
Either way is fine. If you're more comfortable with
vibrations are perpendicular.
to
Sorry.
perpendicular to what?
Perpendicular to the direction of energy transfer.
Okay. And for longitudinal?
They are parallel to the direction of energy transfer.
Correct. Okay, that's it. Actually, that's how you would state the difference. Always go to the definitions. Okay. So, okay, I'll have to revert. I'll have to refresh first. All right. So while that's refreshing, okay, that's it for question 5. Now question 6. We have a ripple tank. Oh, more waves. Okay. So, okay. So the teacher measures the time taken for 10 wave fronts to pass the mark, and then repeated 3 times, and then calculated the mean. What's the advantage of repeating measurements and calculating a mean?
To reduce the effect of random errors.
Okay.
Like to ignore references to anomalous results.
Correct. Okay. So, so again, this is to minimize the, as you said, this is to minimize the effect of random error. That's it. You just have to say that and you're done, because it's only 1 mark.
Okay.
Okay. All right, next question is here. You're given these measurements. Calculate the mean frequency and give your answer to 2 sig figs.
Okay.
Okay.
Excuse me, sir. I'm getting a phone call from my mom.
Sure.
Okay, if I answer it.
Sure.
Thank you, sir. Okay, I'm back. Sir.
All right. Okay. So carry on. This. Oh, not that. Here. That should be fast. Okay. So here's the question.
Okay.
Okay. You have an answer yet?
So, yep, I got an answer.
Mm-hmm.
Answer is 8.4 plus 7.8
Mm-hmm.
plus 8.1
Uh-huh.
divided by 3 equals to 8.1,
Okay.
which
Correct.
is the mean.
Okay. So the mean
And then
is
8.1 divided by 10.
okay. So mean is 8.1, right?
Yeah.
And then what? And then?
And you find the frequency
Okay.
by dividing by 10.
Okay. So, mean... Okay, so divide by 10. So, divide by 10.
Yeah.
That's going to be equal to
0.18.
0.81, right?
0.81, sorry.
Yeah. Okay, and then what? Is that the answer?
So the frequency you'd write it as 1. You'd write it as 1 over 0.81.
Okay. Frequency equals correct. 1 over 0.81. Correct. So, what's that gonna give you?
1.2345 continuous.
Okay. Okay, 0. So, okay. 1 over 0.81 is... Okay, 1, 2, 3... You know what? That's quite an interesting number we'll get there, though. Mathematically speaking. 2, 3, 4...
Yeah, 1, 2, 3, 4, 5.
Yeah, that. Okay, but of course, go back to the instructions. 2 sig figs. So, your final answer must be to
1.2.
1.2. Don't forget the unit. Of course, it's given already in the blank, right?
Hertz. Yeah.
Hertz, but let's just put it in either way. Okay. Great. Perfect. You got 5 marks on that one. You haven't missed a lot of marks on this paper, have you? Alright.
Yeah, I've been studying a lot, sir.
Nah, that's good for you. Alright, next one. So in a different investigation, the teacher wanted to determine the speed of water waves in a ripple tank. Teacher did not measure the wavelength. So explain how the teacher could determine the speed of the wave.
Can measure the time taken.
For what?
For the wave to travel the distance.
Okay. Okay. So you find a distance and then then find the time taken to find that distance, and yeah. Then what do you do with those values? I know it's obvious, but you have to state it, right? So, okay. So let's just put it in here. So again, you said, okay, he already said measure a distance, right? For the wave distance to do what? Okay, then second one is measure the time to travel the distance. You said this part, right? Said distance. And then afterwards, what's the third step? You find the speed, right? By doing what?
Yeah, divide by speed.
By distance over time.
Yeah. But yeah, distance over time.
Okay, basically you have to say, again, obvious as it is, you really have to say everything carefully, okay?
Yeah.
Now here's the thing. Measure a distance. What exact distance do we need to measure here? We can say that one wave front, right, travels.
Sorry, I can't hear you, sir. It's very laggy.
Okay, so again, you need to measure the distance that one wavefront will travel. You have to be a bit specific here. I think, though, that it's fine if you don't say exactly this, but it would be safe to do this. Okay. Alright, can you hear me now?
Yeah, I can hear you.
Alright, good. So... right, let's go to the next part of the problem. Okay, next one. This is another question. You have a cyclist riding a bike. Force A causes the bike to accelerate forward. This is a tricky one. What's the name given to force A?
Friction.
Friction.
What
How do you know it's friction? I know it's
do
tricky.
you mean by?
Yeah.
Are you being sarcastic when you said tricky, or?
Well, a bit because a lot of students are not actually aware that it is friction. Okay. You understand why it's friction, right?
Oh, okay.
From why
Yeah.
why is it friction?
Because
Because
anyway, it's making contact, which
yeah,
means it's friction.
yeah. If you think about it, this section of the wheel is moving backwards, right? So friction will oppose
Yeah.
that motion. So the friction is actually the driving force. It's making it go forward. Okay. Anyway.
Yeah.
Okay, so here is a figure. Here's a graph. Velocity
Okay.
time graph. I'll just copy that on the Jamboard so it's easier to look at. Or like this first. Yeah. So determine the distance traveled by the cyclist between Y and Z. Okay. So I'll just put this here so you can refer to it. And then question. Determine the distance. Okay. I'll just go back to the graph to make it bigger, like that. Adam, do you know the formula for the area of a trapezoid or trapezium?
Formula for area or region?
Yes. If not, it's okay. But if you are familiar with it, it's gonna be faster to solve this.
I am familiar with it.
Okay. You can use that. It's gonna be easier.
Trapezoid.
Okay.
Trapezium or trapezoid?
Trapezoid.
Oh, I thought you said trapezium. No, I don't.
Yeah, trapezoid.
No, I don't know the formula for it.
Okay. Alright, if
I
not,
could just split it into
yeah.
3 different shapes.
Actually, 2 is enough. Because you're only going from Y to Z, right?
Sorry, yeah, two. About 2, yeah.
Uh-huh.
Sir, can you just help me to find where the 2 shapes?
Oh, okay. Your 2 shapes are here. Hold on. I gotta go to the Jamboard so it's easier. I'll make this bigger for the moment. Okay. What are your 2 shapes? Here. And okay. I think I better use my pen. It's easier. Okay.
Oh, okay.
So you see the shape here. And then we have this shape over here.
So it's only after the climax.
Yeah. Because it's only between Z and Y. Okay, I'll keep that zoomed in for
I
now.
didn't read that bit. But
Yeah.
I didn't read that point.
Oh, okay, better make that bigger for now. There. Oh, by the way, Adam, do you mind if we finish like about 2 minutes early? So because I have another class after this.
Oh no, of course it's fine.
All right. Okay. Thank you.
We're just what time does lesson end?
It finishes in about 25 minutes. 24.
Okay. So it'll end it in 22 minutes.
Yep.
Okay, I got it.
Okay, what's your answer?
162 meters.
Correct. Alright, I'll get this smaller now to fit everything. Correct, it is 162 meters. Okay, how do we do it again? Just get this area. And then get this area.
Add it to the area of the triangle.
Yep. So let's just say area 1 and area 2. So distance is equal to area 1 plus area 2, which will be 162
2.
meters. Okay, correct. All right. Okay, let's see. We still have 3 slides left. Let's see if we can fit it in. Okay. So we have the gears of the bike here. Let's a bit. And describe how the force on the pedal causes a moment about the rear axle. So how does this force provide a moment here?
I actually don't know, sir.
Oh, okay. In this case, we'll discuss this, okay? The moment of a force is also known as the turning effect because of that force, right?
Yeah.
Okay, so what's happening here? The first part here is that the pedal, the force on the pedal, creates a moment on it, right?
Yeah.
The pedal turns, thus the pedal turns along with gear A turning along with it. Okay. Okay. So that's the first part of it.
So could you excuse me for once?
Sure.
Just one second.